the horizontal stretch of a graph. Okay, horizontal stretch is represented by b, a number in front of x or theta. All right, what this means is that our normal period, our fundamental period of the graph, okay, is going to change. So now one period of the graph is either going to be more than 2 pi or it's going to be less than 2 pi. So to find the new period, what we do is divide the fundamental period by b. Now remember, fundamental period is 2 pi, or if we were working with degrees, it's going to be 360 degrees, right? Because those are equivalent. So if you look at this example here, all right, we're looking at cosine again. Here is my normal cosine curve, right, from 0 to 2 pi. Well, if you look at this other one that I've put on here, here's one complete cosine curve, right, from maximum to maximum, from the top of the wave to the top of the wave. So what's happened is this is horizontally shrunk, and if we're looking at this one, it started at 0, one complete curve went to pi, so the period changed, okay? And we are going to see twice as many cosine curves where we would normally only see one. All right, so let's look at this one. Y equals sine of 2b, beta, whatever we want to call it. And guys, I'm going to use degrees on this one just because I can. And sometimes that's what it will be. So we've got 90, 180, 270, and 360. And then normally we're up one and down one. Okay, now I look at A, okay, if there's an A here, because we've learned about A and there's not one, so it's just 1, so that part's normal. And then we have 2, okay? So here's the deal with that. I'm going to take my normal period in your mind or over to the side, and I'm going to divide by that number, which is pi, okay? Well, we're using degrees here, so instead of that, I'm going to say 360 divided by 2, which is 180, right? Or we could just say pi is the same thing as 180. What this means is normally I would go from 0, okay, to 360 for that sine curve. Now I'm only going to have to go to 180 degrees. So the easiest thing to do here is to take whatever this new period is and divide it by 4, because everything we do is in fourths, okay? So if I take 180 and I divide it by 4, I get 45. What this is telling me is now, instead of looking at a point every 90 degrees or every pi over 2 if we were in radians, I'm going to be looking at every 45 degrees. So halfway in between 0 and 90 is 45, and then halfway in between 90 and 180 would be 135. So I'm still starting at 0, 0, and I'm still going to go up 1, but it's going to be at 45 degrees. Then I'm going to go down 1, and that would be at 90 degrees. I'm going to go down another one, that would be at -1. And then I'm going to go up 1, and that's at 180 degrees. And now it still looks like a sine curve, but it's happening in half of the interval as it normally would. Okay? All right, amplitude. Our midline is the x-axis, right? And we went up 1 and down 1, so the amplitude is 1. Our period is what has changed here. This is different from our parent graph. We went an interval of 180 degrees, and we were able to see a complete sine curve. The domain, right, is still going to be all reals because we're only graphing one period, but technically it keeps going. And then the range is the normal parent graph range, which is -1 to 1. Okay. Let's look at this one. Y equals cosine of theta over 2. Another way to write this would be y equals the cosine of 1/2 theta. So if that helps you, we'll look at that. Okay, so we'll do this one in degrees as well, just so we're doing some different stuff. Or actually, we'll do this one with radians. So normal period is 2 pi. We're going to divide it by b. b, right, that's this number here, is 1/2. Well, you divide by 1/2 is the same as multiplying by 2, and so we get 4 pi. So this one is going to be stretched. So I'm going to do this one a little bit differently. The last one I did my normal points. This one I'm going to say, all right, listen, we're starting at 0, okay, but I have to end at 4 pi. That's going to give me one complete curve. And then we're going to take that 4 pi and we're going to divide it into force, which means we're looking at something happening every pi. So we've got pi, 2 pi, 3 pi. No a in front, so we're only going up 1 and down 1. Then I'm going to put my cosine curve on here. So we start at 0, 1, go down 1, down another 1, up 1, and back up. And here is a complete cosine curve. It has been stretched. Okay, so the amplitude is still 1, right? Our midline here, this is the middle of our graph. We're going up 1, down 1. The period is 4 pi. Okay, normally, guys, you would have seen one cosine curve and it would have gone like this. Okay, so this stretched and we had to go a lot further to see that one curve. Domain is still all reals. Range is still -1 to 1. It's the period that was changed. All right, so let's look at one where we put them both together. All right, I see number 1, I'm going to have a reflection. I also see A is 2, amplitude of 2, and I have a B. So let's start with the amplitude. What this means is with the amplitude of 2, I'm going to be going up 2, and I'm going to be going down 2. And I'm going to go ahead and put in the amplitude is 2. Okay, now because it's cosine, normally we would be starting here at +1, but we're going to stretch it to 2, but that negative means instead of starting at a maximum at the top, I'm going to start at the bottom. So I'm going to be starting at -2. All right, then this 3 right here, and I'm going to go back, I'll do this one with degrees, just to do something different. So 360 degrees is our normal period. We're going to divide it by 3, which gives us 120 degrees. Then I'm going to take that 120 degrees, I'm going to divide it into force, which is 30 degrees. So every 30 degrees is where we're going to have to plot a point. So we've got 30 degrees, 60 degrees, 90 degrees, and 120 degrees. And when we draw our own x and y axis, guys, it makes it very hard to really see the shrink and the stretch. We know that. The point is that we conceptually understand what's happening. All right, so now I'm going to plot my points. So we're starting at -2. We're going to go up 1, up 2. Then we're going to go up another 2 at 60 degrees, back down 2, and then finally back to where we began at 120 degrees, though, this time. And here's our cosine curve. Okay, so the period is what has changed here, 120 degrees to see a complete curve. Domain is still all reals. Okay, range is also changed. We're going from -2 to +2. Okay, last thing, evaluating. Okay, and I'm actually going to just go on to this one just because of time. When we're evaluating these guys, it's really about order of operations. So, for example, given this function, I'm going to find f of 0. So, f of 0 would equal -4 times the tangent of 3 times, we're plugging in 0 for theta. That's what this is asking us to do, which means, hey, if I were to graph this and the x value was 0 or theta was 0, what is my y value? That's what we're looking for here is our y values. So we plug this in, and we're going to do order of operations here, so 3 times 0. So I'm going to have -4 times the tangent of 0. Then we're going to do unit circle. So we have -4 times, what's the tangent at 0? It is 0. And then we multiply, and -4 times 0 is 0. So if I were to graph this function here, when x is 0, y is 0. Okay, let's do f of 135 degrees. So f of 135 equals -4 times the tangent of 3 times 135. Okay, so order of operations, we're going to multiply first. So we'll have -4 times the tangent of 3 times 135. That is 1,000 and what did I do? 15. Sorry guys, little technical difficulty there. I think you were paused. Hopefully I fixed it. Okay, so don't remember the last thing I said, but we're doing 3 times 135. Okay, 3 times 135. So that's 270 and another 135. That's going to be 405 degrees. Okay, so then we need to find what is the tangent of 405 degrees. So tangent at 405 degrees, well, if we're looking at that, that's too big, that's not on our unit circle. So think about your coterminal angles that we learned last unit. I'm going to subtract 360 from this. And if I subtract 360, I get 45 degrees. So coterminal angles, we know, have the same trig values. So we can use 45 degrees instead. The tangent of 45 degrees, that's what we're going to do next. Unit circle is 1. And then -4 times 1 is -4. Okay? And our last one we need to do is pi over 6. So f of pi over 6 is -4 times the tangent of 3 times pi over 6. First thing we do is that order of operations. So we've got -4 times the tangent of pi over 2. Next we do unit circle. Well, the tangent at pi over 2 is undefined. So at that point, guys, we're done. And the answer is undefined. Okay, now what is the amplitude of this function? Well, remember, amplitude is the distance from the midline to the max or the midline to the minimum. Tangent doesn't have a maximum or a minimum, so therefore there is no amplitude. And as a matter of fact, if you think about your six trig graphs, the only ones that have a max and min are sine and cosine, which means sine and cosine are the only ones with an amplitude. Okay, now what is the period? Well, we're not graphing it, but we can still find the period. Remember what we do? We take our fundamental, our normal graph period, and we divide by b. So our period for tangent normally is pi, but we're going to divide that by b. Okay, so in this case that's 3, so our period is pi over 3, which means this has shrunk. We would not have to go pi, we would only have to go pi over 3 to see a complete tangent curve if we graphed this. All right, tonight's assignment is worksheet number 1.